Well, hello, 4Cs. We're going to have a cosine law lesson today. This follows directly from our sine law lesson that we had last class. So, the same as with sine law, this is used for non-right triangles, although you can use it in a right triangle. It's just that it's significantly more complicated than SOHCAHTOA. So our goal today, I can use the cosine law to find angles and side lengths in non-right triangles. Now the reason we're learning cosine law is because there's two situations that sine law will not do for. And we know, or we found out yesterday, that sine law has to be used if you have an angle and a side across from it that both have numbers on it. So if we take a look at this case 1, you have values for two sides and an angle between them, and you need to find the last side in the triangle. Well, we can't use sine law because here's our angle, and we don't have the side that's across from it. In fact, that's going to be what we have to find with cosine law. So I can't find that answer. So we need cosine law, and the formula for this is going to be c squared equals a squared plus b squared minus 2ab cos c. Now there's no a, b's, and c's in this triangle here, but all you really need to know is that when you have this, where you have two sides and the angle between them, that the a and the b are the two sides that make up the angle that you're given, and the c is the side across from the angle that you've been given, and the angle c is the angle that you've been given. Now, why is this called the Pacman? I'm glad you asked. It's called the Pacman because we have two sides that are eating an angle, and it just kind of looks like Pac-Man to me. I don't care if it doesn't look like Pac-Man to you. It looks like Pac-Man to me, so we're going to call it the Pac-Man. The other one is you're surrounded, and I call it you're surrounded because you have all three sides. So we've surrounded the triangle with known information, but we don't have any angles at all. And so we're going to use cosine law to find the angle in this situation, and we need a different formula. Well, technically it's actually not a different formula, it's just a rearranged version of this one. So this is what it looks like when it's rearranged to find the angle. Cos c equals a squared plus b squared minus c squared over 2ab. So this finds a side length, and this one finds an angle. And we're going to show you how to use them. So this first one, what are we trying to find? It says determine the length of n. So n is a side, so we're finding a side length, so it's got to be this one we're using. So let's write down the Pac-Man. C squared equals a squared plus b squared minus 2ab cos c. I don't know if you noticed this or not, but this is very close to the Pythagorean theorem. In fact, the first part of it looks very much like the Pythagorean theorem. We just corrected for the fact that it's not a right angle that we have. So, carrying on. When we use this one, the A and the B are the two side lengths we're given, and the angle C is the angle between them. So we're going to do 25 squared plus 13 squared minus 2 times 25 times 13 times the cos of the angle between them, which is 105 degrees. So now we're going to pull up a calculator here to type that in. I'll put it over here so you can see what I'm typing. 25 squared plus 13 squared minus 2 times 25 times 13 times the cos of 105. And we get 962.2. 962.2. Now, if you're wondering why that's such a big number, when we have 25 here and 13 here and 962 here, it's because we're not done. In order to get c, we have to do the same thing we did with Pythagorean theorem, which is to take the square root of both sides. So c is going to equal, let's take the square root of our result, which is 31, approximately. And the units here are centimeters, so we make sure to put our units there. Now you might want to pause this so that you can get everything copied, but I'm going to go on. Now this is one where we're trying to find an angle. It says determine the measure of angle C. Well, so we can write down the year surrounded formula. Cos C equals a squared plus b squared minus c squared over 2ab. Now when you're plugging into this formula, the most important thing to remember is that whatever angle you're trying to find, in this case it asks us to find angle C, that the side across from the angle you're finding is the subtracted side. That's very important. It doesn't matter what these are called. It just matters that whichever angle you're finding, that the side directly across the triangle has to come after the subtraction sign in the formula. So this is going to be 500 squared plus 650 squared minus 750 squared, because 750 is across from the angle we're finding, divided by 2 times 500 times 650. Now we're going to plug into this. Let's pull up the calculator again. And I'm going to do this in a few different steps. We have to find the numerator first. So 500 squared plus 650 squared minus 750 squared equals 110,000. 110,000. And 2 times 500 times 650 is 650,000. And now we'll make that division. 110,000 clear. 110,000 divided by 650,000 gives us 0.1692. Now remember to leave it to 4 decimal places so you don't get any early round off errors. And this is cos C. In order to find C, we have to use cos -1. So we're going to do cos -1 of 0.1692. And let's pull that up on our calculator. And we have to go shift cos of what our result was. And that's 80.3 approximately. And that's in degrees. Okay, so now we have a word problem here. This isn't a very difficult word problem because they've given you a diagram. So if they give you a diagram, it's basically just an elaborate knowledge question. An air traffic controller is tracking at T, so it's here, is tracking 2 planes, U and V, flying at the same altitude. How far apart are the planes? So it's asking us for this distance. How far apart are the 2 planes? And it has given us 2 side lengths. And it hasn't directly given us the angle between them, but it has certainly given us enough information to find the angle between them. So if you take a look, this whole angle here is 75, and this angle in here is 23. So in order to figure out what the angle between those 2 lines are, we take 75 and subtract 23, which gives us 52 degrees. Now this is the Pacman situation. We have our 2 angles with, or 2 side lengths with the angles between them. And we need the Pacman formula. So let's pull up the Pacman formula. C squared equals a squared plus b squared minus 2ab cos of c. And we're going to plug in, remember the 2 side lengths are our a and our b, and the angle is our C for our capital C there. So 10.7 squared plus 15.3 squared minus 2 times 10.7 times 15.3 times the cos of 52. Let's plug that into the calculator. Something just happened here. Oh, there's my pause. Okay, my tablet pen just conked out, so I'm going to have to do the rest of this with my mouse. So if my handwriting gets really nasty, you'll know why. So we're going to punch in this here. Clear it. So 10.7 squared plus 15.3 squared minus 2 times 10.7 times 15.3 times the cos of 52, cos 52, and hit equals. So 147, almost exactly 147. So 147, oh, that's so much worse. 147 decimal 0 is what it was, so we won't even put that there. But remember that that is c squared. And so to get our final answer, we're going to have to take the square root of both sides. So this is c on this side, and we have to do the square root of 147. So we'll pull this up again. Square root of our result is 12.1. 12.1. This is in miles, so we should put miles on the end. You can see that that's an M and an I. And there should be a concluding statement here, but I am not going to write that with my mouse because that would take me forever. So we are actually done. So now you have some homework to work on here. You got question number 4, question number 7 and 10, and then 13 and 15. And don't forget to check your answers. And if you have any questions, I will hopefully be able to answer them for you when I am back on Monday. Have a good weekend, everybody.